Mastering Multi-Cloud Deployments with Terraform, a practical guide to AWS and GCP integration. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Managing infrastructure across multiple cloud providers can be complex and time-consuming in today's cloud-first world. Terraform, an open-source infrastructure as code (IAC) tool, offers a powerful solution to streamline and automate the deployment of resources across multiple clouds like AWS and GCP. This podcast will explore how to manage multi-cloud deployments using Terraform with practical examples efficiently. Understanding variable definitions for AWS and GCP resources. Terraform's key strengths are its ability to manage resources flexibly and make them reusable using variables. Variables allow you to abstract specific details about your infrastructure, making your Terraform configurations adaptable to different environments. For instance, when defining variables for AWS and GCP resources, you might have something like this. Variable AWS_region. Description equals the AWS region to deploy resources. Type equals string. Default equals US West 2. Variable GCP_project. Description equals the GCP project ID. Type equals string. Default equals my GCP project. Variable instance_type. Description equals the type of instance to deploy. Type equals string. Default equals t2.micro. These variables can then be used throughout your configuration files to ensure consistency and ease of modification. GCP instance creation with conditional logic. Terraform also supports conditional logic, which can be particularly useful when deploying resources in a multi-cloud setup. For example, you might want to create a GCP instance only if a specific condition is met. Resource Google_compute_instance default. Count equals var.deploy_GCP. 1, 0. Name equals GCP instance. Machine_type equals E2 medium. Zone equals US Central 1A. Boot_disk. Initialize_params. Image equals Debian Cloud/Debian 9. Network_interface. Network equals default. In this example, the Google_compute_instance resource is only created if the deploy_GCP variable is valid. The count parameter controls this, a powerful way to manage conditional resource creation in Terraform. AWS instance creation with conditional logic. Similarly, Terraform allows for conditional logic when deploying AWS resources. For instance, you might use a similar setup for creating an AWS EC2 instance. Resource AWS_instance default. Count equals var.deploy_AWS. 1, 0. AMI equals AMI 12,345,678. Instance_type equals var.instance_type. Tags equals. Name equals AWS instance. Again, the count parameter controls whether the AWS instance is created based on the value of the deploy_AWS variable. This makes managing resources across different cloud providers easy based on specific criteria. Provider configuration for AWS and GCP. Before deploying resources in AWS and GCP, you must configure the appropriate providers. Terraform's provider block allows you to define the connection details for each cloud provider. Provider AWS. Region equals var.aws_region. Provider Google. Project equals var.gcp_project. Region equals US Central 1. This setup ensures that Terraform knows which cloud provider to interact with and how to authenticate. Executing Terraform commands for infrastructure management. Once your configuration files are ready, managing your infrastructure with Terraform is straightforward. Here's a typical workflow. Initialize the working directory. Terraform init. Preview the changes Terraform will make to your infrastructure. Terraform plan. Apply the changes to create or update resources. Terraform apply. Destroy resources when they are no longer needed. Terraform destroy. These commands are fundamental to Terraform's operation, allowing you to manage your infrastructure lifecycle easily. Controlling resource deployment with the test variable. In more complex deployments, you might want to control whether certain resources are deployed based on an environment variable like a test. This can be achieved as follows. Resource AWS _instance test _instance. Count equals var.environment equals test. 1, 0. AMI equals AMI 12,345,678. Instance _type equals t2.micro. Tags equals. Name equals test instance. In this example, the test _instance resource is only created if the environment variable is set to test. This allows you to tailor your deployments for different environments, for example, production, staging, testing, without changing the underlying code. Conclusion. Terraform simplifies multi-cloud infrastructure management by offering a consistent and flexible way to deploy resources across different providers. By understanding variable definitions, using conditional logic, and mastering Terraform commands, you can streamline your multi-cloud deployments and maintain control over your infrastructure. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.